Hello, this is Mr. Miller. Welcome to video 1A, our very first calculus video. Today it's just me, but as the videos go on, we're going to have a lot of special guests, especially some great helpers from Gear Up. Today in this video, we're going to talk about factoring. We're going to talk about how to simplify rational expressions using factoring, how to solve quadratic equations by factoring, and at the end, there's a journal assignment for you. In your journal, you're going to write video 1A, copy the problems, and solve them. All right, let's get going. So our first problems here are two factoring problems. So these aren't too bad. So remember, it's all about finding the right two numbers and splitting up this middle term. So we're going to look for two numbers whose product is A times C. Remember, this is A, this is B, and this is C. So A times C is 42, and we're looking for two numbers whose product is that and whose sum is B, which is 13. So it turns out that these two numbers are 6 and 7. Okay, it wasn't too hard this time. So 6 times 7 is 42, 6 plus 7 is 13. That's how we split up the middle term. So this is 2x squared plus 6x plus 7x plus 21. So all I did was split this 13x up into 6x and 7x. But it's like magic. Now we can factor by grouping. So I can write this one as 2x times x plus 3. And I know I'm going to need an x plus 3 on this side. So since I have 7x plus 21, it looks like I need a plus 7 there. Okay, now both terms have this x plus 3, so I can factor it out. So what's left is 2x plus 7, and then times the x plus 3. And we did it, we factored it. Let's take a look at this one. I'm going to write P for product. So the product is A times C, which is 5 times 3 is 15, and the sum is negative 16. So I need two numbers whose product is 15. Sum is negative 16. Turns out that negative 1 and negative 15 work. I know they have to be negative because the product is positive, but the sum is negative. So it must have two negatives. Okay, so we're going to split up the middle term. We have 5x squared minus 1x minus 15x plus 3. So I'm going to group those. I can pull out an x here. It's x times 5x minus 1. I better have a 5x minus 1 over here. This isn't going to work. So if I think, what do I need to put here so that whatever I put here times 5x minus 1 is that? Well, I need a minus 3. I think that makes it work. That'd make it minus 15x plus 3. That does. So now factor out the 5x minus 1. And we have x minus 3 times 5x minus 1. So we went over this a bunch of class, and I know you're good with it, but I want to try a little bit trickier ones. So on these, finding the two numbers is not as easy. But in class, I mentioned the use of a sum table. It's a very powerful tool. Okay, so when we start factoring this, we know that the product has to be A times C, which is 2 times 114, which is 228. Kind of a big number. And we know the sum has to be 31. Off the top of my head, I don't know two numbers that add to 31 and multiply to 228. I mean, we could try some things, but the table is going to do it systematically for me. So remember, you take the sum and divide it by 2. 31 divided by 2 is 15.5. But if they're decimals, we round down and we round up. 15 plus 16 is 31. And we want to see what 15 times 16 is. So 15 times 16 is 240. So we got two numbers that add to 31, but they don't have the right product. It's too big. So we're going to make one go down and the other one go up. These still add to 31. But 14 times 17 is 238, which is a little bit better. I'm going to keep going. Make this go down by 1. This go up by 1. We get 234. We're getting close. If I make this go down by 1 more and this up by 1 more, 12 times 19 is 228. We've done it. We found the two numbers who multiply to 228 and add the 31. So now the factoring is going to go kind of the same. So I'm going to have plus 12x plus 19x plus 114. So notice that the 114 is the same as up there. Sometimes people change that, but you shouldn't. I'm only splitting up the middle term. All right, so this is going to be 2x times x plus 6 plus, I know I need an x plus 6 here, so this better be a 19. And that works. So we get 2x plus 19 times x plus 6. All right, let's try one more example like this. Here we go. So this one has a negative in the middle, but that's fine. We can handle this. So the product is 12 times 55, which is another big number. It's 660. And the sum is negative 52. So again, I'm going to divide this by 2. When I divide by 2, I get negative 26 is fine. So this time I don't have to round down and up. I'm just going to start with negative 26 and negative 26. Negative 26 times negative 26 is 676. That's not that far off from what I'm looking. But I'm going to skip a few. So instead of going up by 1 and, down by 1 and up by 1, I'm going to go down by 3. I'm going to skip a couple. I'm going to go up by 3. Okay, and if I went too far, I can always go back. But negative 29 times negative 23 is 667, so I'm close. I'm just going to go down by 1 more and up by 1 more, and I have it. That's 660. Okay, so this is actually a really systematic way, and you can factor anything. This is not an easy thing to factor at all. So this would be really hard otherwise. So here we go. Plus 55. Right, looks like the greatest common factor is 6, so this is 6x. I'll be left with 2x minus 5. I know I need a 2x minus 5 here, and to get the minus 22x, it looks like I need a negative 11. So I get 6x minus 11 times 2x minus 5. Done, it's powerful. So that is not an easy problem at all, but we got some good tools if we need them. All right, I want to switch gears. This goes way back. I want to talk about simplifying fractions, and the reason why is we need to do this when they're variables. So when we simplify a fraction, we need to find the greatest common factor of the numerator and the denominator. I know you know how to do that, so I'm going to tell you what it is. For 20 and 32, the greatest common factor is 4. So I can write the numerator as 4 times 5, and the denominator as 4 times 8. Now, we can cancel factors in the numerator, and let me explain why. Because I could write this as 4 over 4 times 5/8, but, oops, my 8 moved, but you get the idea. And 4 over 4 is 1, so this is 1 times 5/8, which is 5/8. Now normally we just cancel the 4's and say it's 5/8, but I want you to understand why. Because 4 over 4 is equal to 1. Right, between 42 and 60, the greatest common factor is 6. So I can write this as 6 times 7 and 6 times 10. I can cancel factors of the numerator and denominator. 6 is a factor of both, and that leaves 7/10. All right, here, the greatest common factor is 14. So we can write this as 14 times 5, and 84 is 14 times 6. So if you cancel the 14s, you have 5, 6. All right, now this is going to get a little bit more challenging here. So here we have what's called a rational expression. It has a polynomial in the numerator and a polynomial in the denominator. Just like with the numbers, we need the factor. So that's why I left a lot of room here. X squared plus 4x plus 3. I need two numbers whose product is 3 and whose sum is 4. Well, 3 and 1. So I can write x squared plus 3x plus 1x plus 3, or x plus 3 times x. I need an x plus 3 here, so this must be plus 1. I have x plus 1 times x plus 3. Wow, that's the numerator. So we can use all our tools of factoring to factor that. And I think I'm going to skip some details here because we went over that. So we got to factor 2x squared plus 7x plus 3. So you can use the methods we've done, but this turns out that this is going to factor as 2x, x, and I think I need a plus 1 and a plus 3. Yeah, that works. So I just did kind of a trial and error method. So if it's not too bad, we can use trial and error, or you can use, like I said, the methods we've shown. All right, so once we have a factor, that's really the hard work. Simplifying is easy. They both have a factor of x plus 3, so we can cancel it. And this is equal to x plus 1 over 2x plus 1. That's simplified. Now, for every value of x in the world, these two things are equal except for one value. And we're going to talk about that later when we talk about limits. So I just want to plant that in your mind. These are equivalent except for one number. We'll find that one number later. Let's try this again. So here we have to factor this. We have x squared plus 3x minus 10. That actually factors into x plus 5 and x minus 2. We also have x squared minus 3x plus 2. And that factors into x minus 2 times x minus 1. So once I have them factored, we're going to substitute their factored form. So this is x plus 5 times x minus 2. Down here is x minus 2 times x minus 1. We see what they have in common. If they have something in common, we can cancel. So they have an x minus 2 in common. So we're left with x plus 5 over x minus 1. The reason why I bring this up, we're going to need this when we're discussing limits very soon. Alright, this is the last slide, and I want to show you something else that you've done in the past. Solving quadratics by factoring. We can always use the quadratic formula, but I want you to see how to do it by factoring. So the first step is to factor the left-hand side. We have tools to do that. So I'm just going to kind of jump to the factored form. So if you factor this, you would get x plus 9 times x minus 2. You can check my work by using a TI-89 also. Remember, it'll factor for us. Equal to 0. Now, it's important that this equals 0. We have a product of two things that are equal to 0. And the zero product property of real numbers says that if a product equals 0, then either the first quantity or the second quantity has to be 0. So if you think about it, the only way we can make this 0 is if either x plus 9 equals 0 or x minus 2 equals 0. Remember, this is called ZPP, zero product property. If I solve this, I get x equals negative 9 or x equals 2. Now, if x were negative 9, this first factor would be 0. 0 times anything else is 0. And if x equals 2, that makes this second factor 0. So whatever the first one is, times 0 equals 0. So our two solutions are 2 and negative 9. All right, on this one, our last problem, we want to factor this. So again, I'm going to assume we know how to do that. 3x plus 2 times x plus 1 equals 0. So again, it's important that it equals 0. This property doesn't apply if it equals any other number. All right, so set them equal to 0. 3x plus 2 equals 0. If you solve that, you're going to get negative 2/3. Or x plus 1 equals 0. If you solve that, you get x equals negative 1. All right, so factoring is very important. Factoring is going to be helpful for simplifying expressions. It's going to be helpful for solving quadratic equations that aren't too bad, where we don't need the quadratic formula. And it's going to be useful for other things. All right, time to show you know it. So here's the journal assignment right here. And copy these 4 problems into your composition book. Label it video 1A at the top, so I know where to find this assignment. And show your work when solving these. Good luck.